Hello everyone, I am Jaykirti from TYEIDS and today I am here you to explain related to the concept feeding images to the convolutional neural network, and it is known as the CNN. And these slides introduce the main topic, how images are processed and learned by the convolutional neural network, a powerful type of a deep learning model and used especially for the image classification. At the end of this session you will be know what is the batching, preprocessing and the crucial steps within the CNN architecture. Okay, and the next slide is about the representation of the images. Image as a matrix means every image can be broken into the small blocks or the pixel, and each has a number indicating the color intensity. Means when we are proceeding an image to a system, the image is broken into the smaller pieces or in the pixel forms or the blocks. So in the 3D tensor, for the color images, they are 3D tensors, heights, width and the channel. So for CNNs, as image is stored as a 3D matrix where height and width and image size. So the channels 3 for the RGB, so it indicates that red, green, blue. Okay, the grayscale image, one channel. If the black and white, only one channel is used in the grayscale. So one real world example is Instagram filters works on RGB values of images to change how they look. Okay, so it is the next slide is of the pre-processing of images. So it is a pre-processing of images. So in that it is a resizing, normalization and data augmentation. So resizing, standardized input size for consists the model processing. Okay, so all the images must be in the same size before feeding into the images in the resizing. And in normalization, scales pixel values typically from 0 to 1, improving the training stability. So pixels from 0 to 225 are converted into the 0 to 1 range, which helps the speed by learning. So the next one is the data augmentation. In the data augmentation, it rotates the image or flipping or cropping the image. In flipping, it flips from vertically to horizontally or horizontally to vertically, and we can increase the data diversity to prevent overfitting. Okay, so preprocessing helps standardize and improve training by stimulating more diverse data. One real world example is the self-driving cars. A CNN might learn to detect pedicides from various angles using augmented images. Okay, the next slide is batching of the data. Efficiency processes data in the small batches, not the full data set at once. Means instead of all the data, CNS takes a few images at a time, like a batch. Means instead of taking a huge data, it takes like a group, means batches, a number of batches like 10 batches of images, like this. Memory management significantly improves the memory and efficiency during the training. Okay, so reduces the memory load. Using this process, it decrease the memory load. And parallelism, optimally utilize the parallelism on the powerful GPUs for the faster computation. So GPUs can process multiple images at once efficiently. Batching makes CNN training faster and manageable on the limited hardware. One real world example is When you upload multiple photos to the Google Drive or Google Photos, it processes them in the batches to detect faces. Okay. So next slide is about the feed forward pass. In that we have convolutional layer, activation layer, pooling, and the fully connected layer. So in convolutional layer we have this layers detect the hierarchical features in this image, means apply filters to detect patterns like edges, colors and shape. In the activation function, the ReLU activation function is used. So it introduces the non-linearity, allowing the complex patterns learning. Okay. So it helps the CNN understanding the complex things by adding the non-linearity. In the pooling, we have downsample features maps to extract the dominant features, means reducing the size of images representation while keeping the important details. Okay. And the next one is the fully connected layers. In that performs the final classification based on the extract features. Okay. So connecting the features to the final decisions or the predictions. The summary of this slide is feed forward pass is the path images takes through the CNN to get predictions. One real world example is in Google Lens, the image you can scan goes through the convolution, pooling and prediction layers to tell you what it is. Okay, when we pass an image to the Google Lens, so this all four steps works at a time. Convolution layer and activation layer and pooling layer, this whole four step works at a time and give us the image. We form like a image and we can understand what is this image. Okay. So the next slide is about the output layer. In the output layer we have the features like feature conversion and softmax activation and probability output. So feature conversion, in the feature conversion it converts the learned feature into the meaningful prediction, means last layer gives the final answer like it is a cat, dog or a car. And in the softmax activation function, it often uses the softmax for the multiple classes and the classification task, means converts the output into the probabilities. Okay. So in the probability output produces the probability distribution over all the possible classes, and the highest probability indicates the predicted classes. Okay. So output layer gives the final answer from the CNN. A real world example means medical diagnosis. CNN might say 80% chance is pandomia, 15 normal and 5% bronchitis. Okay. The training the CNN, we have the features like input data and backpropagation and loss optimization and optimizes and the epoches. Okay. In input data, training begins with the paired image and their corresponding labels. So images plus labels input, model sees the images and correct the answer the label. Okay. The loss optimization, the model optimize a chosen loss function like a cross and entropy to minimize the errors. Okay. So measures how wrong the model is in the loss optimization. In the backpropagation, gradients are calculated and propagated backward through the network. Okay. So backpropagation plus optimizer adjusts the model to be more accurate in the backpropagation. So it works like means in the optimizer it works means it removes the error and adjusts the model to be accurate. And in epochs means iterations, how many iterations, in how many iterations it forms the correct output. So the entire process repeats for the multiple epochs and refining the models and the performance. So training the entire data set once is one epoch, usually done for the many epoch. Epoch means iterations. Okay, so the training is where the CNN learns from the label the data. Okay, the real world example is just like a student saying from the answer in a textbook. A CNN learns by the comparing its guesses to the right answer and correcting itself. Okay, the next slide is about the evaluation and the testing. So in that we have the validation, matrix and the testing. Okay, so in validation, models are validated on unseen data during the training. So model is tested on the new examples it isn't seen before, means which has not been experimented already. So it works on the new data which has been not processed before. In the matrix, the key matrices like accuracy, precision and recall are used to access the performance. So the matrix like precision, accuracy and the recall, this all makes the images perfectly. And testing, and in precision, how many predicted positive were actually corrected. And in accuracy, overall correctness is checked. Okay, so in the testing, a separate tester set verifies the model's generalization ability on the new data. Okay, evaluation checks how good the model is before real use. One real world example is before launching an app that detects the plant disease, its CNN is tested on thousands of new leaf images. Means when we launch one app, means when we launch a app, the users or the who have made that app, they checked twice or thrice before launching an app. Same the process is done in the evaluation and the testing. Okay, now the next slide is about the CNN interview questions. Means what we learned previous, in that based on that we are having the interview questions. So the first question is, how is an image represented when fed into a CNN? Do anyone know? If no, then you can answer your in the comment box. So the first question answer is tests understanding of image to matrix conversion. Okay, and why is normalization important? Do anyone know? To see if you know how it improves the training efficiency. And what is the role of pulling less? To test understanding of dimensionality reduction and features importance. Okay, how does a CNN learn during the training? Checks your graphs on the loss, backpropagation and the optimization. Okay, and the next question is about the explain the purpose of data augmentation. Accesses your knowledge of generalization and the overfitting. And what happens during the feed forward pass of a CNN confirms your concept of the internal working of CNN layers. Okay, and thank you for your attention. We hope this presentation provided clear insights into how images are processed by a convolutional neural network. Your questions are welcome and we ensure further exploration of this dynamic field. Thank you so much.